All right, for lesson 4 in this first part of the statistics unit, we are going to look at data analysis. So just analyzing the different data values. So, and first thing that we need to know is what an outlier is. An outlier is a data point that is way out of range in regards to the other data points. So something that's way higher than the other values or way lower. For example, in our classroom, Miss Eider and I would be outliers because we are, in terms of age, because we are older and we don't really fit in with your age group. So in this data set, what would be an outlier? Which one stands out? If I look closely, I see 276. Everything else is in the 40s and 50s, and then we've got something in the 200 range that's way out of place in regards to the others, so that would be an outlier. So what we're going to look at first is how outliers affect the mean and the median. So we're going to be looking at some original data sets and then how it changes, or a change data set from there, and how that changes the mean and the median and so on. So there were 4 dogs at a vet's office. The weight of the first 3 dogs were 52 pounds, 48 pounds, and 50 pounds. The 4th dog weighed 22 pounds. If the dog that weighed 22 pounds left the vet, how would the following measures of center of the data set be affected? So, first thing I want to look at is what the question is asking. It says, and I'm going to highlight it, if the dog that weighed 22 pounds left the vet, how would the following measures of center of the data set be affected? So we're saying our original data set was 52, 48, 50, and 22. We had those 4 dogs. So you'll notice up here we have our original data set put in order for you, what the mean would be and the median would be. So you don't have to calculate that for the original set. What we do need to do is look at our new data set. So we're saying if the dog that was 22 pounds left, so this 22 pounder is no longer going to be included. So now I'm going to list out my new data set in order. So 48, 50, 52. So first thing I'm going to do is I'm going to calculate the new mean. So I'm going to add up all of those values, 48 plus 50 plus 52, and we get 150 divided by 1, 2, 3 numbers gives you a mean of 50. For the median of our new data set, I'm just crossing off my lowest, my highest, what value is in the middle, 50. So now we're just going to answer these 2 questions. Did our mean increase, decrease, or stay the same with the new data set? So it was 43, now it's 50. That is an increase, it went up. Then our median. Did it increase, decrease, or stay the same? It went from 49 to 50. So it went up, not by a lot, but it did go up. So what we have to think is, why did it go up? Well, we took out this number that was an outlier. It was way smaller than the rest. We took that out. That outlier brought down all the values, so once you took it away, those values went up. Let's look at number 2. Baxter Healthcare has 3 accountants with the following salaries: $50,000, $60,000, and $55,000. For extra help during the tax season, they hired an intern with a salary of $10,000. How would the following measures of center of the data set be affected by the new hire? So, first thing again that I'm doing is I'm going to highlight what this question is asking. It's saying, how would the following measures of center of the data set be affected by the new hire? So our original data set is without this new hire. Our new data set is when we factor that guy in. So originally we just have the 50,000, 55,000, and 60,000 in order from least to greatest. But when we're adding in this intern, that makes, it's an outlier because it's way less than the rest, 10,000 compared to 50,000 plus. That's going to be our lowest value, so 10,000. And then the rest is in the same order. So 50,000, 55,000, and 60,000. So we're going to calculate our new mean first. I'm going to add up 10,000 plus 50,000 plus 55,000 plus 60,000 and divide it by, and there's 4 employees, so divide it by 4. We get a new mean of 43,750. For our median, we are crossing off our lowest, our highest. If I crossed off 50,000, I'd also have to cross off 55,000. So we can't cross them both. We're circling them both. They are both in the middle. So to find our new median, we need to add these two together. 50,000 plus 55,000 and divide by 2. So the median is 52,500, which again, double check. Does that make sense? Is that in between 50,000 and 55,000? Yeah. So now let's look at analyzing our data. Our mean was originally 55,000. Now it's 43,000. That went down, that decreased. Our median was originally 55,000. Now it's 52,000. That also went down. So why did it decrease this time? Well, we added in an outlier that was way lower than the rest, so it's bringing down the average, right? Like if you had a test grade, if you had a test that was way lower than the rest, it's going to bring down your grade. All right, last example like this. Adam and his 3 friends are in a bowling league. His friends' all-time high scores are 180, 224, and 205. Adam's all-time high score was 250. After this week's game, he has a new high score of 290. Wow, he's good. How would the following measures of center of the dataset be affected by Adam's new high score? So again, I'm going to highlight that. How would the following measures of center be affected by his new high score? So our original data set is 180, 224, 205, and Adam's original high score of 250. What we have to think about for the new data set, we had 1, 2, 3, 4 values. We still have 4 values because you can't have more than one all-time high score. So what happens is he no longer has this all-time high score of 250, and instead it's being replaced with the new high score of 290. So where the 250 was, now we have a high score of 290. But everyone else has stayed the same. 180, 205, 224. So let's go ahead and calculate the new mean. 180 plus 205 plus 224 plus 290 divided by 4 people is 224.75. I'm just going to round that to 224 and 8/10, so 224.8. For our new median, we are crossing off lowest, highest. I can't cross off both of these, so both of these are in the middle. So we find the median by adding them together, 205 plus 224, and dividing by the 2 values, and we get 214 and a half. So let's first look at the mean. It originally was 214. Now it went up to 224, which makes sense because his high score went up, so the mean went up. Like if you got a better grade on the most recent test, your grade is going to go up. The median was 214 and a half. It still is 214 and a half. It stayed the same. And what we have to think about is, because the number that was replaced was this number on the end, so it was going to be crossed off anyways, and that left us with the same middle values no matter what. The last thing we are going to look at is, we're going to skip over the U-try for now. You can come back to it after. We're going to look at how to determine the best measures of center. So we have 3 different measures of centers, and we have 2 different measures of variation that we look at. But sometimes some are better to use than the others, and some are going to be more representative of the data. We are eliminating mode from our best measures of center just because sometimes the most common number might not be something that's in the middle of the data. It could be the lowest value or the highest value. And more often than not, mean and median are going to be the best. So the 2 things we want you to focus on are deciding when would I use the mean and when would I use the median. So we would use the mean when there are no outliers in the data set. So all of your data values are relatively close together is when we would use the mean. Okay? Versus we would use the median when there are outliers. So for example, in this one, 283 doesn't really fit in with the rest of the data. The rest of the data is in the hundreds. So now, based off of what one is our best measure of center, that's going to determine our best measure of variation. So we use the MAD, which stands for the mean absolute deviation, when the mean is our best measure of center. And then we use the IQR when the median is our best measure of center, because we have to use the median to find the IQR. So a mean person would make you mad, those 2 go together, and then median and IQR go together. So determine the best measure of center and variation for the following data sets. Number 4, first thing we're looking for is, are there any outliers in this data set? So when I'm looking at this, right away I see 31. Everything else is like in the 90s or the 100s. 31 is way far off. So there is an outlier. When there are outliers, the best measure of center is the median. And our reasoning is because there are outliers. Well, if we use the median, that means our best measure of variation is the IQR. Because the median is the best measure of center, which I'm just going to abbreviate as MOC. All right, number 5. I'm looking, I see some 80s, some 70s, all relatively close to each other. So there are no outliers. When there are no outliers, the best measure of center to use is the mean. And why? Because there are no outliers. Well, if we use the mean for our best measure of center, the MAD is our best measure of variation. And why? Because the mean is the best measure of center. And then the last one. So I see some 520s, 530s, 520s, 530s, 520s, 530s, all relatively close to each other. So I don't see any outliers. No outliers means the mean for our best measure of center, because there are no outliers. And if we use the mean, we use the MAD. Mean makes you mad. And then because the mean is the best measure of center. Now you can go ahead and do the 2 U tries.